We've made history by touching the sun. Well, almost. NASA's Parker Solar Probe became the first spacecraft to enter the outer layer of our star and survive. This monumental event took place in April 2021, but scientists revealed the news only in late December. However, this mission isn't just about adding another milestone to humanity's list of achievements. The primary goal of the Parker Solar Probe is to study the sun's inner workings, particularly to help us predict its powerful flares that could be catastrophic for Earth. Already, the probe has discovered something extraordinary. Why does the solar wind sometimes blow in the opposite direction? What other strange phenomena might it uncover inside the sun? And most importantly, could we survive an impending solar hurricane in the coming years? The sun operates in a relatively simple way. At its core, hydrogen fuses into helium, producing immense energy, 700 billion tons of fuel per second, equivalent to the mass of 100,000 Egyptian pyramids. However, the sun does not emit energy evenly. One of its most dangerous anomalies is a coronal mass ejection, a massive flare that, if directed at Earth, could disable all electronic devices. Predicting these emissions is difficult since we can't see the far side of the sun where they originate. The corona, the sun's outermost layer, is visible only during an eclipse, and it was precisely here that the Parker Solar Probe ventured. It detected plasma flows with temperatures reaching 833,000 degrees. Interestingly, the spacecraft soon exited the zone, as the corona isn't a perfect sphere, but rather an irregular shape resembling a dented golf ball. During its journey, the probe also identified peculiar solar wind anomalies known as switchbacks, where charged particles momentarily reverse direction before returning to their original course. This phenomenon resembles a Whip's shockwave, but is still poorly understood. Could the answers lie deeper within the sun? If the probe were to go further, it would pass through the photosphere, where temperatures drop to 2,200 degrees. Scientists still struggle to explain this drastic temperature difference. The photosphere is also home to solar granules, massive convection cells, each as large as Texas. These regions mark the origin of switchbacks, where heated plasma from the deeper convection zone surges upward. Beneath this, the convection zone extends 200,000 kilometers deep, where plasma churns like boiling water in a pot. Below that lies the radiation zone, where pressure is so high that plasma no longer moves. Here, hydrogen atoms are packed so tightly that they only exchange photons, which take thousands of years to reach the sun's surface. In fact, the sunlight we see today was generated long before the Great Pyramids were built. Some scientists even speculate that anomalous forms of life could exist within stars, potentially composed of charged plasma particles, which might explain unexplained luminosity fluctuations in certain stars. Unraveling the mysteries of other stars. Different stars exhibit their own unique anomalies. Proxima Centauri, a red dwarf, is 10 times smaller and much cooler than the Sun, with a surface temperature of just 2,000 degrees. Unlike our Sun, red dwarfs lack a radiation zone, causing hydrogen and helium to mix freely throughout the entire star. Sirius A, on the other hand, is a blue-white star twice as massive as the Sun and 25 times brighter. It burns through its fuel rapidly, shining brilliantly but living a much shorter lifespan. Such stars eventually collapse, leaving behind white dwarfs or neutron stars, some of the strangest celestial objects in the universe. The threat of space hurricanes. In early March 2021, scientists observed a space hurricane for the first time, a swirling mass of plasma above the North Pole, 1,000 kilometers wide. Based on current predictions, an even more powerful space hurricane could strike Earth in 2025, bringing severe consequences. NASA warns that such an event is inevitable. A massive solar storm could cripple electronic devices, just as a geomagnetic storm did in 1921, disabling half of New York Central Railroad's equipment. With modern society's heavy reliance on electronics, the impact would be far worse. If a major solar storm were to hit, electricity grids would fail, communication systems would collapse, and transportation networks would be thrown into chaos. To prepare, consider adding these essentials to your survival kit: a bicycle, reliable transportation when cars and trains are inoperable; binoculars for observing the breathtaking auroras caused by solar storms; canned food and baby formula, long-lasting nourishment when fresh food becomes scarce; firewood and matches, essential for cooking and warmth without electricity; a gun for personal protection in an increasingly unstable world. The worst-case scenario. If the 2025 solar storm is severe, life as we know it could change dramatically. Within months, GPS systems would fail, and within a year, society would struggle to rebuild. Some experts suggest that in such a scenario, an underwater bridge between Sweden and Denmark could serve as an ideal shelter due to its sturdy construction and location. While some may dismiss these warnings, history has shown that severe solar storms can have devastating effects. Governments and scientists continue to study space weather to mitigate potential disasters, but individuals should also take precautions. If the worst happens, will you be ready?